Alright, this is going to be our first part of the trigonometry chapter. So we are going to be looking at right triangles. And the hypotenuse of a right angled triangle is the side opposite the right angle. So wherever we are, we find the right angle. Here it is, and we go across, and there's our hypotenuse. Here's our right angle, we go across, here's our hypotenuse. That you should remember from when we did Pythagorean theorem. Then if we look at the angle marked theta, BC is the side opposite theta. So when we find theta, we go across, and we mark that our opposite side. And then adjacent is another word meaning next to. So when we try to find the adjacent side to angle theta, here's angle theta, here's our side that's adjacent to that. And for the angle marked beta, the side opposite, again we find our angle, we go across, and that's the side opposite. And then for our adjacent side, we find our angle that we're talking about, and then we find this side that's next to that. So here's an example. For the right triangle alongside, we want to find the hypotenuse. So if we are here, there's our right angle, we go across, our hypotenuse is going to be YZ. The side YZ is our hypotenuse. YZ. Then the side opposite, our alpha, we find alpha, and we go across, and that's our side opposite from alpha. So that would be XZ. Then the side that's adjacent to alpha, if this is our hypotenuse, it can't be anything else. We've already said this is opposite over here. So next to would be our adjacent, and that is the side XY. So now that we're done looking at our alpha, we need to turn around, and now it wants to ask us questions about the beta angle. So now we're looking at this angle instead, and so the side opposite would be across, so that would be XY. And the side adjacent would be next to, and that would be the side XZ. So if we look at a right angled triangle with an angle theta, and we label the sides, this is the angle we're dealing with, whatever angle it might be. Angle Z, angle X, angle theta, whatever our angle is that we're interested in learning anything about, then we can label our sides. The opposite is across. The adjacent is next to that angle that we're talking about, and then our hypotenuse is always going to be across from our right angle. So that's how we label those sides to our right triangle. Now there's three trig ratios that we're going to talk about at this point, and those are sine, cosine, and tangent, and they all have to do with some angle we're going to call theta. So sine theta is equal to the opposite side over the hypotenuse. Cosine theta is equal to the adjacent side over the hypotenuse. And the tangent of theta is equal to the opposite side over the adjacent side. And all we're doing is plugging in numbers in those spaces at this point. So here's an example where it asks us to find the sine of theta. Well, the first thing we need to do is we need to start looking at what is our sides. If we're looking at theta, this is always going to be our hypotenuse because it's across from our right angle. So always across. This one, well, I thought I was going to erase something. It's not wanting to erase. Okay, so then if we're looking at theta, here's our theta. So this side is going to be the opposite side. And that leaves this side to be our adjacent side. And since we have two that we're dealing with the angle theta, we'll go ahead and work through both of those, and then we'll go look at our other angle. So sine theta, we said on the last slide that sine theta is equal to opposite over hypotenuse. So whatever the opposite is, which we've looked, and we're going to call the opposite B, it's right here. And then we're going to put that over the hypotenuse, which is C. So our ratio for sine theta is B over C. Now our tan theta ratio is opposite over adjacent. And if we look over here, our opposite is still B, and our adjacent is going to be A. So our tan theta trig ratio is going to be B over A. Now if we delete this so that we can look at our other information here. So now we're looking at this angle here. So again, our hypotenuse doesn't change because it's across from the right angle. But now A is going to become our opposite side because it is opposite to this angle that we're dealing with in this problem. And then this one is going to be our adjacent. So when we try to find cosine, we said that cosine is adjacent over hypotenuse. So we look at adjacent, and that's B. And then our hypotenuse is C. So our trig ratio for the cosine is B over C. Now you have a worksheet that's in front of you, or that you should pick up if you have not already. And this is an example problem on the front and on the back. So this one's problem number 1. It asks us to find the tangent of angle Z. So here's my angle Z. I'm going to label all of my sides. If this is my right angle, then this is my hypotenuse because it's across from my right angle. Across from angle Z is my opposite, and next to angle Z is adjacent. So now I'm going to look and say, okay, tan Z, and tan is equal to opposite over adjacent. So we look and we find our opposite is 21. Our adjacent is 28. So we put 21 over 28, and we can reduce that down to 3 over 4. And that's how the entire first page of the paper will work. And then on the back, it asks you to find the value of each trig ratio to the nearest 10,000th. So basically, we're going to take the trig ratio, and we're just going to plug it into our calculator and get a decimal answer. So again, we're looking at Z, angle Z. Here's our right angle, so this is our hypotenuse. Across from angle Z is our opposite, and next to angle Z is our adjacent. And then we're going to do cosine of Z, and cosine is equal to adjacent over hypotenuse. So my adjacent is going to be 12 over my hypotenuse is 15. And when I plug 12 over 15 into my calculator, 12 divided by 15, I get 0.8. So my decimal value of that trig ratio to the nearest 10,000th, so we have to add some zeros, then we end up with 0.80000. And that is how the whole second page of that paper works.